For those who are not familiar with what Pearl is, it's an organization that's made up of 8 like-minded broadcast station owner groups that have names that you're all familiar with, I'm sure. And the remote control is right here. Companies like Tegna, Nexstar, Meredith, Scripps, Raycom Media. They work together through Pearl to find technological solutions that have business possibilities for broadcasting. You know, I think it's no secret that broadcasting in general, whether it be radio or television, is under pressure right now from alternate means of getting content from to homes. And if the industry is not looking for alternatives to enhance their business plan, then there's not any hope for broadcasting on the long term. ATSC3, of course, is one of those initiatives. It's just one of the initiatives, but there are many more. So Pearl is not focused in so much on the standard itself as it is on its business application and how it might be used, or a pejorative term, exploited, to provide a means to keep us all in the lifestyle we've all gotten used to. To that end, in November of last year, the FCC passed a report and order that outlined the possibility for voluntary transition to ATSC3 by broadcasters. No requirement. There was a number of rules about how it would be done and the mechanics of doing the licensing and so forth. But it was done kind of tentatively by the FCC, but I got to give a shout out to Ajit Pai for having the guts to push it through fairly quickly. These kinds of initiatives in the FCC tend to take years, and he managed to push it through relatively quickly. So that is a good thing, because it helps stir the bottom up and gets people thinking about what the future needs to be. When the rules were put through, the Pearl said to themselves, well, geez, you know, in past, during the transition in ATSC1, there was a model station that was put together that did exactly the same thing. I believe it was in Washington, D.C., at the facilities of NBC, I believe, and WRC, and they put on a model station that helped deal with some of the recommended practices, but also to look at the possible business implications of some of the things that were going to happen in ATSC, not the least of which was how the transition was going to take place. The same here. Pearl decided to take up the baton and see what it would take to find or use some of the more interesting capabilities of ATSC3 and see whether they resonate. Whether they resonate with the viewers, whether they resonate with consumer receiver manufacturers to build the receivers, whether they resonate with the manufacturers of the equipment itself, and would they provide those capabilities. As you well know, receiver manufacturers are under no mandate to build anything. We can stand up an ATSC3 television service, and if no receiver manufacturers decide to build receivers, then we don't have a business. So we really have to speak to all of those constituencies, and we have to convince them that we have a service that is well worthwhile investing in and will provide a future for broadcasting that will last a while until the next great thing comes down the pike. So anyway, Phoenix was selected as a location for the model station, not the least of which is there's a number of Pearl companies stations there, but also because there was a presence of at least 3 networks, Univision, NBC, and Fox. We quickly got the support of those stations and those companies as well, which was, we thought, important, because nothing that we can do at the broadcast station level is going to happen unless we get the help and permission of our partners, which are our networks. So getting network buy-in was important. The only way you'll get network buy-in is if they participate. And so, frankly, we got an enthusiastic response from those 3 networks, and they joined us right from the beginning. Also, what is good about Phoenix is you have to know a little, have some experience with marketing, but for some reason Phoenix is a favorite amongst marketing companies for doing tests. It's kind of a easily bounded area that doesn't spill into other areas, and it's easy to quantify. So there's an awful lot of data available on the audience there from all different directions, which was good. And lastly, as an RF environment, it's terrific. It's isolated from other markets by mountains, and also all of the transmission antennas reside in the same spot on top of South Mountain, which is at the south part of Phoenix, and sitting at roughly 2,700 feet. And it provides an excellent transmission platform, relatively free of some of the funnies that come from other markets in which transmission locations are dotted around the market, and you have odd interference issues and ghosting and other things. So those are the partners. There's 12 of them in all, 12 stations that are participating. But also, what's not mentioned here, but is very much a partner, and that's Cox Cable. Cox Broadcasting, which is a different company, although allied with Cox Cable, have some common ownership, is a Pearl member. So by coincidence, and good planning on our part, Cox Cable also is the cable company in Phoenix. And so it gives us a chance to work with the local MSO to do some testing and some development with them as well and bring them along. They have, to their credit, brought in cable labs, and we're not trying to supplant or superimpose what we're doing or what we're trying with what S37 is doing in ATSC, but we want to make sure that we have good relationships with our cable partners, because in the ATSC1 world, as you well know, it's any number between 75 and 80% of our viewers are watching us via some connectivity other than over the air. So it's important to have that buy-in right from the beginning, because that's a long road, as we all know. It's an open and collaborative test bed. We're not going to build a product to sell. We're not making a profit in any of this. We're providing a means by which all of the partners, both the manufacturers and the stations that are participating and the networks that are participating, can try out things, ask questions, see how things really work in a St. Thomas kind of way, put their hand in your side to make sure that what we're doing with ATSC3 is very possible. We want to develop, obviously, a basic TV service. That's a given. There's test consumer propositions. There's a number of capabilities that ATSC3 serves up to us that turn into a business possibility, whether it be alternate content, mobile operation, broadcaster application. It goes on and on. We want to make sure we take a look at all of those capabilities and see what resonates with the audience. Test cable integration, I mentioned that already, and develop an industry framework. One of the good and bad things about ATSC3, and it was mentioned earlier by Matt, is that there's too many choices. It's like coming to a restaurant with a menu that looks the thickness of a dictionary. And that's good. I mean, it's good because it gives you a lot of options, but it's bad because it gives you too many options. And so to get the industry kind of swimming in the same stream, in the same direction, and to give some guidance to the receiver manufacturers as to what they need to build, because they frankly can't build everything or won't build everything. They could build a receiver, I suppose, that would be capable of doing everything that ATSC3 could provide, but it would neither be practical or affordable. So we need to come up with a framework in which it has some bounds that will allow receiver manufacturers to build a product that is reliable, serviceable, and affordable. This really kind of, from a 30,000-foot view, explains what we're trying to test. We're standing up the signal. We can provide a number of different capabilities. but they fall into brackets, and those brackets to some extent overlap. Obviously, signal protection, our networks, the studios, the sport teams will require some kind of signal protection. They're all very, very concerned that they spend millions and millions of dollars creating the content, and then 5 minutes later it gets out on the internet and it's available without regard to the cost of creating the material to begin with. They're particularly sensitive to this because, as you well know, ATSC3 at its base is IP. And because it's IP, immediately in the minds of the lawyers of all of these content creators, that makes it very easy to get out on the internet. Whether that's relatively true or not is not the point. Perception is reality. MVPD integration is important. We need to pave that way because that's going to be a long road, as we all know, and because right at the moment, 80% of our audience is watching us that way. Audience data and addressable advertising is critical. It's one of the things that we need to look at to see first whether it's technically possible, which probably is a problem that can be solved, but we also have to look at it to see whether it makes a lot of sense from a business point of view. It seems like it ought to make good sense, but sometimes the obvious concept isn't correct. So one of the things we want to do is take a look at that from a research point of view to see whether the delta that we get for having a targeted ad overcomes the loss we have in the CUME in terms of the audience that we provide on our base service. So that needs to be looked at carefully. Obviously, the viewer experience is very important. We're competing in broadcasting, whether we like it or not, with the likes of Hulu and Netflix and Amazon Prime and OTT provider du jour that provides a user experience that, generally speaking, is excellent. It's informative, it usually has deep links, easy to navigate, doesn't require a lot of direction on how to do it. They work very hard at making that good, and that's what we're competing with. We can't just do business the way we've always done it and expect we can compete with that kind of capability. And lastly, mobile and mobility, or mobile in automotive is something to think about. It's not just delivering our content to the backseat of a car. The mobile or automotive sector is a huge sector. We don't hear about it a lot, but delivering data to automobiles and receiving data back from automobiles is a big deal. It's one of the legs in the stool of 5G, for example. But 5G is pretty good at one-to-one, but doesn't scale all that well for, let's say, covering a whole 1 million automobiles in a given market. But we have the capability, at least in one direction, of delivering content, whether it be updates to software, be it directions, there's a million things that the automobile manufacturers are all interested in delivering to their captured audience in their automobiles. This leads to a little more drill down, and I'm not going to read them all, but this speaks to the individual proofs of concept, or POCs, as Ann Shelley, that runs Pearl, the acronym she often uses, which is the actual individual requirements that are shown in a little more broad sense in the earlier slide. The one that really resonates with me is the broadcaster application user experience. One of the things that we'd like to do is come up with a common framework in which the overall general wireframe of the experience is the same on all channels. I have to be careful how I say that because we're not interested in forcing you to do anything. But if we want to have an audience that understands how to operate this receiver immediately, then as they go from channel to channel, they should not have to learn the user interface all over again. So there needs to be a general look and feel of the broadcaster experience that's similar, meaning the channel change button is in the same spot and the nomenclature used for volume is the same, maybe loudness on one and volume on the other. But the point being is that those kind of things drive viewers crazy. And having controls on one side and not on the other, or having channel data on one side and not on the other. That kind of business really does not resonate well with viewers at all. And it's one of the things we're going to be looking at during some viewer testing, which I'll get to in a little bit. The rest of it is pretty much we mentioned already. We're on the very bottom, viewer research. We're doing ongoing viewer research, but specifically we're doing viewer research with Maggot in Phoenix in 2 weeks, I believe, that we will have the typical marketing closed room with a glass wall with all of us on one side of the glass and all the viewers and the moderators on the other side of the glass, and they'll be showing them ATSC3 capabilities, if you will, whether it be audio enhanced dialogue, broadcaster application, targeted advertising. They'll be shown a lot of things, and to see how it resonates with them. Some things they may not care about. Other things that I believe that we've already done some research on, like enhanced audio or enhanced dialogue, really resonated. And it's going to be interesting to see how it does with this. You know, we always forget about audio when we're dealing in television. But that was one thing that, you know, just virtually everybody in the room raised their hand about, which was enhanced audio. If you're listening to a loud baseball game or football game and you can barely hear the commentators, and if you're like me at my age, you know, you don't have any high frequency response anyways. So if they can bring that, the guy that's covering the game's voice up above the crowd level by the push of a button, that's a good thing. And it can be done without having to send that as a separate track. So those are the kinds of things that we need to drill down to make sure that we don't miss. Because again, we have to sell this as an experience to that consumer who's sitting in Best Buy or Costco and making a decision on a $1,500 receiver. You know, why should I buy that? And because it says UHD on it, probably doesn't mean anything to them. They have no idea what UHD is. But if they say that it says that it'll make the experience better for watching your football game because you'll be able to hear the commentator, that may be a good thing. So again, that's part of the audience research. We're going to be doing a lot of it. The first of it starts in 2 weeks. We have, obviously, one of the first slides I showed you was the partnership of stations that we have in Phoenix. But we couldn't do all this without the partnership of all the manufacturers. We virtually have just about every one of the ATSC3 manufacturers that are involved in the project. I mentioned it's an open platform, an open test bed. They can bring the equipment in, and that works also for you'll see the consumer manufacturers that are up there as well. LG, Samsung, Sony have brought in prototype receivers and are testing the interop capability between what we're transmitting and what they can receive. And what Matt was mentioning earlier, the very first receivers we got, God love them, they worked, but they worked in Korea, or they worked in Japan with a Korean signal. And you know, their version of ATSC3 was frozen in February of 2017, and it's a quite different animal than where ATSC3 sits at the moment. And so we're trying to work our way, and I'm sure Matt is too, trying to work our way from February 2017 to today. Nobody's equipment, nobody's receivers, nobody's transmission equipment meets the current standard. Nor does it meet the old Korean standard either. It's somewhere July or August of 2018 maybe. It's got a little bit to go. But we're working on that, and I agree with you, we do not make firmware changes if we're in the middle of the test. We're suffering through one right at the moment. But they've made a significant investment, and you'll notice, by the way, that one of the partners we have up there is Avis Rent-A-Car, which is the biggest rent-a-car company in the United States, I think, at the moment. And they have a very big interest in ATSC3 and our ability to be able to deliver data to their customers. One of the things that's always asked, and it's getting to be less and less of a mystery, but it's much more of a, to some people that they may not quite understand how it works, is how ATSC3 Lighthouse will work, how the transition will take place. Take more spectrum because there's an awful lot of pressure internationally on the amount of spectrum that exists. And with 5G being on a huge push, they want the spectrum. So if we're going to do the transition, we have to do it ourselves. So this is how it was done in Phoenix. There's a lot of corollaries to this, and different markets will have different sets of combinations. But this is how we did it there, and it is a general way that can be done just about everywhere. We had Univision that had two stations on the air on South Mountain. And they had the Unimas, which is their sidecar company that is a Spanish language station. And they had Univision, which is shown down on their lower right, KTVW. They were able to move the Unimas station from 1080 to 720. They probably could have got away with 1080, but they went to 720 because they also wanted to carry a 2 multicast. So they moved the Unimas station down to the Univision station, along with the grid and bounce, and with a new encoder and switching to 720p for Unimas and Univision, they were able to fit all of that in that bandwidth. Now, that left two of their diginets, which is get and escape, you'll see on the left. Those are two 480 sidecar diginets. And because Scripps and Tegna are two good Perl companies, we were able to get and escape to be moved down onto their channels. That freed up KFPH completely. And left of 6 megahertz available. It is a low power station, but it's sitting at 2,600 feet, and therefore its coverage is virtually 95% of what the big guys are. They're limited more by the terrain than they are by their output power. So that freed up the 6 megahertz, and you see off to the right, that allowed us to put Unimas on the air in ATSC3. Now we go to the next. That only used a very, very small amount of the total bandwidth. The FCC requires, Matt didn't mention this, but FCC requires that you provide coverage of at least 95% of the coverage that you had prior to transitioning. So, although you can use any mod card you want during testing, and we will, the question is ultimately you have to be able to hold back your bandwidth in a way that allows for mod cards that will replicate your coverage in ATSC1. So all of the other stations are licensing. In fact, we just this week got licenses on the 5 that you see on the left. There's a couple more that will be coming very shortly, and we will be able to add any one of those or all of them onto that one KFPH CD. So that in a thumbnail is the way that you can transition a market. Now there happens to be some stations that aren't covered in a big market like Phoenix, but you just use the same trick with another station. And indeed, the next station that we'll be doing that with is Nexstar, another Pearl station in Phoenix, so that we'll have plenty of bandwidth available on 2 Lighthouse stations. This is just a simple block diagram of what you need to do it. If you haven't seen, this is not every little part and piece, it's just the broad stroke. On the left, you'll see the kind of like decks of cards. Those are input processing and up-down cross conversion and encoders that would be for as many channels or as many streams, as many services, many services as you'd like to carry on a single channel. We have the ability to do 8. So you can either receive this ATSC1 signal off the air, or you can take a fiber feed, or whatever way you want to get the signal over to there. We're doing a combination of both. We ultimately want to get all over into fiber, but right at the moment we're taking off the air and direct feeds from things like video servers for testing. The encoder then go through stat muxes. The stat muxes feeds a packager. The packager puts the NPD and all of the instructions for the receiver to kind of put the whole service together onto a router encapsulator. A stream assignment, which creates the ALP streams that are needed for the gateway and scheduler, and then on out the door. The reason I show this is the amount of hardware it takes to get on the air on the transmission side really isn't enormous. It's relatively modest. And all of this equipment probably wouldn't take up more than a half a rack. So, and it's relatively affordable. You know, they haven't set list prices yet, but I'll say that it's in the $250,000 to $250,000 range for that many channels. I think that's in the range, you think? Yeah, maybe $300,000. So it's relatively affordable in the scheme of things, particularly when we're simulcasting. This is the test schedule that we have going forward. In general, I don't want to spend a lot of time on that because I want to leave time for questions at the end if you have any. We had a recent Plug Fest. 21 companies showed up, 65 participants. We were mainly focused on the high level, mid and high level parts of the signal. We were particularly worried about the route dash interface. Again, another interface that we were having a lot of trouble and struggling with. I think Matt alluded to some of the issues there. The standards are clear. I don't think the standards are in error. I think that there's a lot of misunderstanding amongst manufacturers about what needs to be there for sure and what needs to be there because it would be nice to have it there. And those kinds of discussions with getting everybody in the room at the same time really did a lot to help solve an awful lot of those issues. As you can see down at the bottom, we talked about encoding, packaging, and encapsulation. I think, for those that don't know, packaging is where the MPDs are placed on the streams. And also, obviously, we wanted to deal with NRT because nobody's dealt with non-real-time delivery of files yet. That's still a great unknown. The lessons learned. Early implementations are still not complete. Versioning is a big problem. Every time somebody makes a software upgrade, then everything downstream of it stops working, including the receivers. So it's keeping track of versioning is a big issue. We use Jira, which is a development tool to kind of keep track of all of that and even that, but we don't catch all of it. Dash can work in two ways, either in time or as an index. An index is just counting segments. We're really pushing hard to use time. We had a long discussion with everybody, and we've all come to the conclusion that the time is really the way to do it. And not that index is broken, but it's just really makes life a whole lot easier. CMAF, which is something that's coming out of MPEG, and really it's an industry-driven for over-the-top to deal with the problems of restitching together and it's platform agnostic. So it's good way of keeping track of segments in any adaptive encoding methodology. It's not in the ATSC yet. They haven't dealt with it. It needs to be dealt with on the dash level, the dash IF, and then once it gets dealt with the dash IF, then it'll get rolled into. But we're really pushing hard for that. We came to the conclusion that push was really necessary. You can either push or pull the information out of the packager into the scheduler, into the encapsulator, and push is really the only way that it can work. It will not work with pull. The only thing that we want to have the option of using pull for is for over the top. As you all know, part of ATSC 3 is the ability for us to drive over the top simultaneously. So the over the top signal will be pull, and the push signal will be for broadcast. We all came to the conclusion that SCT triggers were the best way to interface with the X-links that will be needed later on for, and SCT's triggers are already supported by most traffic systems now anyway. The interchange between equipment is still not there yet. I'm not going to spend a lot of time on it because we don't have a lot of time, you can't buy a packager and buy an encapsulator and connect them to it and expect them to talk to each other. They won't do it. It requires some custom voodoo right at the moment. It shouldn't require that. And they're all really good about it. Trevini's great about it, you know, Harmonic's great about it, but he should be able to connect the two IP connections and have it work, you know, but it doesn't. And that's versioning and it's misunderstanding of the our receivers and early prototype equipment we have don't support a lot of stuff, like AC4. The only reason we have AC4 in the air is because we have some prototype equipment from Dolby. None of the manufacturers make AC4 encoders yet. If they tell you they do, they're not telling you the truth. So they're all coming, they're all working on it, but if you get AC4 on the air, it's because you have Dolby equipment. And Dolby isn't in the equipment manufacturing business. They have equipment because it won't get on the air if they didn't have the equipment, but it's equipment they don't sell. Protecting the MPD, this is a big issue with a lot of people, not just the networks. If we're going to be doing targeted advertising, we kind of advertise that we're going to insert an advertisement in the MPD that will contain our advertising pod. And there is a way, and you don't have to be terribly clever, that you can read the XML that comes out of the MPD, that comes out of the packager, that will kind of advertise the fact that a break is about to come. And we're pushing very hard that, and we'll have a thing go to ATSC 3, that maybe that ought to be encrypted. If we encrypt the MPD, and the receiver manufacturers say that it won't cause them a lot of trouble, then we have a way of preventing, and we'll encrypt all MPDs. So they, you know, somebody, the bad actor that's out looking at your, and trying to skip over your commercials, they won't be able to tell whether they're looking at a commercial pod MPD or whether they're just looking at another segment. So encryption of that MPD, I think, is the key to making it work. Looking forward, most of the stuff I already mentioned. The only thing I didn't mention on that list is we intend to stand up an SFN. We're going to be standing that SFN up. In fact, we're working on it right at the moment, and hopefully getting it on maybe by July or August of next year. Awful lot of work to get that going, particularly in a market like Phoenix, where the ground is like concrete. And just digging a hole takes you all week. So.